Hey, Algebra 1B. Today we're going to look at problem set 68, and we're going to look a little more with complex fractions. Now, this is a topic that we have already dealt with, but we're taking it one step further, and the problems are going to get a little bit messier. Okay, so far we have had complex fractions where maybe it's a fraction over a fraction, like, I don't know, 2y over z. Okay, and so far what we've dealt with on this is when it's one fraction over one fraction. Our little rule or our little process has been take the bottom fraction and flip it over times the top. Okay, and when it's one fraction over one fraction, we can do this pretty simply, and we get something like this. Okay. Now, the difference with this lesson is you're going to notice that within these fractions we have some addition or subtraction. So our process is going to change a little bit. And I'm going to show, there's a couple of different ways we can do this, but I'm going to show you what I feel is the easiest way to handle these problems. Okay, so what we're going to do, when you look at this first example, let me label this number 1. Okay, when you look at this complex fraction. Again, a complex fraction is a big fraction that contains little fractions. First thing, make sure everything is a fraction within there. So you have 1 over w plus c over w plus 1 over c. Okay? Sometimes we'll have to make little fractions out of things. But on this one, everything is already a fraction. So look at all the denominators. I have a w, and a c. What I want to look at is if I were to get a common denominator for all three fractions, for every little fraction inside of there, what would it be? In this case, with the w's and the c, my common denominator would be cw. Now, I'm going to use that to simplify this problem. And the way we're going to use it is I'm going to take cw and I'm going to multiply that to every fraction within the big fraction. Okay, the reason we multiply by it is so that it will cancel the little fractions. So on the first part, cw times 1 over w, the w's cancel, and I'm left with c times 1, which is c. Plus, in the second part, c over w times cw. Again, the w's cancel. This time I have c times c, which is c squared. Now, there's no more fractions on top because they've been canceled off. Now I move down to the bottom. I have 1 over c times c over w. This time the c's cancel. 1 times w is w. So look for like terms in the numerator. C plus c squared, those are not like terms. I cannot cancel anything. So this is my final answer. Okay? Really not too bad. So hopefully this is an easy topic. Let's look at problem number 2. In this problem, the first thing I want to do is I want to make sure each little part is a fraction. So this 5, I'm going to make it a fraction. Put it over 1. Okay, so now I have 4 little fractions inside this big fraction. I look at all the denominators. What would the common denominator be? In this case, I have m, and a 1. My common denominator would be m. So I'm going to go in here and I'm going to multiply every fraction by m. All 4 fractions get multiplied by m. All right, and again, the reason we do that is so it cancels the little fractions. So m times 1 over m, the m's cancel. I'm left with 1. Plus 5 over 1 times m, nothing cancels on that one, so 5 times m is 5m. All right, no more fractions on top. Move down to the bottom. M times 2 over m, m's cancel, that's what we want. I'm left with 2. Minus x over m times m, m's are gone again. All I'm left with is x. All right, again, look for like terms in there on the top or on the bottom. We don't have anything here, so again, this is our final answer. All right, now this last problem. This one gets a little tricky, and if you look at it, you have some negative exponents. This always messes people up because what you naturally try to do is take the things with the negative exponent and just move them up or down. That doesn't work when there is an addition or subtraction sign within the fraction. Okay? When you see that, what we're going to do is we're going to turn this into a complex fraction. So you got to look at we basically have three little parts here inside this big fraction. I'm going to make each part a fraction. So x to the negative first. That x is going to move down, but it's going to move down inside its own fraction. So the a is going to stay, the x moves down underneath it. The power is now positive 1. That's still inside a big fraction. Plus, now I have y to the negative first. That part is going to become its own fraction. The b stays on top, the y moves underneath. Power is now 1. Okay, then down on the bottom, x to the negative first on the bottom of the fraction. I need to make that a little fraction inside of this. So x moves down, power is positive, and I have a 1 left on top. So when you see those negative exponents, you're going to make little bitty fractions inside the big fraction, and that's all because of that plus sign right there. Okay, so now it looks a lot like the first two examples. We'll look at all the denominators, figure out what the common denominator would be. In this case, I have x, y, and x. So my common denominator is x, y. I multiply every term by xy, or every fraction by xy inside of there. And the whole reason, again, is to cancel the fractions. So xy times a over x. X cancels. I have a times y is ay. Plus b over y times xy. The y's cancel this time. So I have b times x is bx. And then move down to the bottom. 1 over x times xy. X is canceled. 1 times y is y. Now, watch it. Can I cancel the y's here? Your answer should be no because of the addition. The only way I could cancel a y is if I could take a y out of every term. But when there's addition there, I can't do any canceling. All right, so this is my final answer. All right, that's our complex fractions. Okay, again, make every little part a fraction, figure out what the common denominator would be, and you're going to multiply every part by that common denominator to cancel the fractions, and then just simply reduce. Okay, this is problem set 68. Good luck.